Okay, this series looks a little weird just because we're usually not thinking about tangent of 1 over n. First thing that comes to mind is let's check that the terms go to 0. So this is the nth term divergence test. So the question is the limit as n goes to infinity, tangent 1 over n equal to 0? Because if that limit is not equal to
It's
0,
12:30.
thank you. If that limit is not equal to 0, then we can stop right here and say that the series diverges. Well, the limit n goes to infinity of tangent of 1 over n is equal to, well, let's see. As n goes to infinity, 1 over n is going to go to 0, and tangent of 0 is 0, right? Because it's sine of 0 over cosine of 0, and sine of 0 is equal to 0. Cosine of 0 is equal to 1. So this was a bust. We've got to try something else because the limit of the terms is equal to 0. Doesn't look like it's a good candidate for ratio test or root test because I know nothing about the tangent of 1 over n plus 1 over tangent of 1 over n. This doesn't speak to me. Nothing is canceling out. So I'm thinking no to the ratio test. I am thinking no to the root test because tangent of 1 over n, the nth root of that, who knows what that is, right? That doesn't seem to simplify things. Integral test. Maybe the integral test will save us. I don't know the integral of tangent of 1 over x dx. That does not look familiar. Yikes. So, no to the integral test. It's not geometric. It's not a p-series. Things aren't going to cancel out, so it's not a telescoping series. So the best we can do is to try to compare. So we're going to need to use a comparison test. So we've got tangent of 1 over n. And the only thing I can think of, what I'm thinking of, is let's just compare it with 1 over n. Right? So if we look at, so let's try to do a limit comparison test with 1 over n. That's the only thing that's standing out to me, and it might just be because 1 over n is the argument of tangent. So I need to know what is the limit as n goes to infinity of tangent 1 over n over 1 over n. Right, this will be L, and if L is greater than 1, then both the series converge or diverge. Or actually not if L is greater than 1. If L is any finite number, then both of the series converge or both of the series diverge. Lucky for me, not lucky, this is on purpose, I know that this is the harmonic series, and the harmonic series diverges. Right, so if this limit, if L is some positive finite number, then by the limit comparison test, our series must diverge, just like the harmonic series. Okay? What is this limit? In order to compute this limit, so I need the limit as n goes to infinity of tangent of 1 over n divided by 1 over n. I'm going to use L'Hopital's rule. So using L'Hopital's rule, I'm going to instead compute the limit as x goes to infinity, tangent 1 over x divided by 1 over x. And why can I use L'Hopital's rule? Because this is an indeterminate form, namely, as x goes to infinity, tangent of 1 over x, this is going to 0, and the denominator is going to 0. So let's use L'Hopital's rule to say that this is equal to the limit as x goes to infinity. In the denominator, I need the derivative of x to the negative 1. So that'll be minus x to the negative 2. And in the numerator, I need the derivative of tangent of 1 over x. So that will be secant squared 1 over x times the derivative of 1 over x, right? Because I need my chain rule. All right, so things are going to cancel out, namely the derivative of 1 over x, and I'm left with the limit as x goes to infinity of secant squared 1 over x. As x goes to infinity, 1 over x is going to go to 0, and secant squared of 0 is equal to 1. So my limit L is equal to 1. And since L is a positive number, by the by the limit comparison test, both of my series converge or they both diverge. Since I know that the harmonic series diverges, that means that my original series must diverge. So I go back here, and my answer choice is diverge.